Good evening, YouTube. It's a pleasure to be back with you all. Tonight we have another installment of our Python Koans series. Make a little bit more progress. The channel's up to 25 subscribers, which is very exciting. I was just thinking a few weeks or months ago, not even months, a few weeks ago, we were celebrating subscriber number 6 in the comments. So yeah, the number just keeps growing. And I would just say that I find this stuff just a ton of fun. A lot of fun solving these little riddles and learning about technology. So I'm glad you guys are all here with me along for the ride. And we'll just keep going, see how it goes. All right, so as you can see, we are in our Python Koans directory. And if you recall, to see where we are in our adventure through the contemplation of these koans, we need to run the contemplatekoans.py file. So we'll say python 3 contemplatekoans.py. And as a quick reminder, you'll see in the output when you run the file what what tests you already have passing and where you are at in terms of the file you're in and the test you are on. So in this case, we are in the thinking about list assignments file, and we are on the test non-parallel assignment has damaged your karma test. All right, so let's jump into that. Here's a little message, a little Easter egg. Explicit is better than implicit. And I think that is true. When you write programs, when you write code, you need to think about the people that need to read and perhaps maintain those programs a year from now or 10 years from now. And if you've got knowledge and hidden things going on, implicit knowledge that's sort of built into your code, that can make it more difficult for someone down the line to consume and quickly understand your code. So explicit, being explicit about things, is better than being implicit. All right, so let's go to about list assignments.py. Command T, about list assignments.py. All right, and let's see, we were on line 13, so we've just started this. And then this is about array assignments in the Ruby koans. All right, so we've talked about that. Line 11 here, we've got a test, and it's called test non-parallel assignments. Test non-parallel assignment. So we've got names in an array, or I should say in a list. We've got a list with 2 strings inside, and that list is saved to a variable with the names. We're going to say in our assertion self-assert equal, and then the question is, what is going to be equal? I do not know. Maybe it's going to be something like this, which I don't think makes a ton of sense, but we'll see what it gives us. Run the test. All right, so that was actually correct. Test non-parallel assignment has expanded your awareness. Okay, so that's pretty straightforward, I think. The next one, test parallel assignments. Okay, so we've got 2 variables, and they are set to the value of an array with 2 strings inside, John and Smith. So we've got a list, or I keep saying array. I think in Python it's proper to say list. We've got a list with 2 strings inside, the first one being John, the second one being Smith. And then those are set to 2 variables this time instead of 1, which is interesting. And so what I think this is telling us is that you can take multiple variables and pass them or set them to a list, and the values of those variables will take the values within the list. So for example, self-assert equal, I will say, I'm going to assume this is John. So the variable first name gets assigned to the first value in the list, which is the string John. And the variable last name gets set to the second item in the list, the string Smith. So let's run it and see if that worked. And it did. All right. Next one. Test parallel assignments with extra values. Okay, so we've got 3 variables now set to a list with 4 items inside, 4 strings inside. So what's going to happen here? I'm going to assume that title will be set to the first value, that first names, interestingly, this variable has a splat operator or a star in front of it. And that typically means it can be expanded to, I guess, be assigned to multiple things, or it's like an expansion thing, an expansion operator that it probably means like, oh, first names can be several things from this list. So let's give that a try. I'm going to assume first names probably becomes something like this: Ricky, Bobby. So because of the star syntax or the splat syntax here, I assume, which I don't know for sure, we're going to find out in a second, that that variable will be set to an array of all items in the middle of the list that aren't the first item or the last item. And then I think perhaps last name will get set to Worthington. All right, let's see if that is correct. And it is correct. So that's how it works. So the first variable gets set to the first item in the list using this syntax. The variable with the splat operator in front of it gets set to a list of everything between the first and last items in the original list. And then the last variable gets set to the final item in the list. Test parallel assignments with fewer values. This is curious. All right, so I'm going to assume, based on what we just said, that title will get set to Mr., the first string in the list. First names, I'm going to either guess an empty array or nil. I'm not sure what that's going to be. And then last name will get mapped to the final item in the list, Bond. Let's see if that's correct, and if I was correct about my assumption on the middle variable getting set to nothing or to nil or to an empty array. That was correct. So it got set to an empty array because there were no items to set it to, because they were all consumed by the first variable and the last variable. Test parallel assignments with sublists. First name, last name, all right, so 2 variables, one first name and one last name, are set to a list, and the first item in that list is another list with 2 strings inside of it, and the second item in that outer list is a string Johnson. All right, so let's see. What does first name get set to? I assume that it gets set to the sublist, right? The first item. Let's see if that's correct. The first item with its inner contents, I should say. All right, and you may have seen that my IDE shows all these weird colors, and that's when I'm making a syntax mistake, FYI. All right, and then I'm going to assume last name is Johnson. Okay, and let's save that and run it. That appears to have been correct. All right, so moving on. Test swapping with parallel assignment. So we have a variable set to a string, Roy, a variable first name set to a string, Roy, on line 38. On line 39, a variable last name set to string, Rob. On line 40, we have two variables already defined, first name and last name, and we're setting them to the same two variables but in opposite order. Now, I assume that swapping refers to setting a one variable to another, swapping their values. So if first name was originally on line 38 set to Roy, but then we swapped it to have the value of whatever last name was based on this syntax on line 40, I assume first name will become Rob. And therefore last name will become Roy. And let's see if that is correct. All right, that's correct. So now we are on to another file, and it's called aboutdictionaries.py. So Command T in Sublime Text if you're following along, aboutdictionaries.py, and we'll get started. All right, so this is based on about hashes in the Ruby cones. Okay, so in Python, a structure that's called a hash in Ruby is called a dictionary in Python. So class about dictionaries. All right, so we've got a class with some methods. Effectively, they are tests inside. And we want these tests to pass, so we need to implement the code that makes them pass using our test-driven development pattern that we talked about in an earlier video. All right, so empty dict on line 12 is a variable, and it's set to some keyword dict, looks like a method that takes no argument. Okay, so I assume that's going to be an empty dictionary. All right, so we're going to say assert equal that dictionary and type empty dict are the same. Okay, so we're basically asserting that empty dict, the value that it holds, is of type dictionary. It's a data type of dictionary. Assert dict equal. All right, so we're saying, okay, we're going to assert that this empty dictionary, which is what this squiggly line syntax is. That's how you can create a dictionary using like the English word or the method to create the dictionary, or you can use this syntax of the two squiggly lines. So that's something to keep in mind. And we're saying that this is equal to whatever empty dictionary is. So it's saying that these are equivalent using the two squiggly lines or using the method dict with no argument passed in. All right, so assert equal, something needs to be equal to the length of empty dict. All right, so I believe the length of empty dict is going to be 0 because there's nothing inside of it. So let's go ahead and run it. And that was correct. All right, moving on. Test dictionary literals. All right, so on line 18, we've got a variable called empty dict again, and it's set to an empty dictionary using the squiggly line, or I should say the bracket. I think squiggly line, bracket, I think they're the same. Anyway, no, not bracket, brace. Bracket is the square ones. All right, so squiggly line. No, it's got to be bracket. I can't remember. Assert equal, it's a dictionary. Assert equal dict and type empty dict. Okay, fine. So yes, that empty dict created using that syntax with the braces is still of type dictionary. That's what this assertion on line 19 is claiming. Now on line 20, we've got a different variable called babblefish, and it's set to a dictionary, but this time there are contents in the dictionary. And we've got, looks like 2 items in the dictionary separated by this comma here. The first item is a mapping or a pairing of some kind, and the second item is a mapping or pairing of some kind. At least in Ruby, and I assume in Python as well, we call these keys and values. So inside of a dictionary, we're going to have a key, and it's going to be mapped to a value, just like in a real life dictionary where we've got a word and it's mapped to a particular meaning. So you can look up the word and find the meaning. Okay, and then all of that entire structure inside this dictionary is set to be the value of the variable babblefish. So now on line 21, we've got an assertion, assert equal, what is the length of babblefish? My assumption is that the length of babblefish is 2 because there are 2 items in the babblefish dictionary. Let's check that. Tab, what's happening? All right. I believe that was correct. Okay, dot. All right. Test accessing dictionaries. So on line 24, we've got a variable babblefish, and it's set to a dictionary with 2 items. One mapped to the string uno, the key 1 mapped to the string uno, and the key 2 mapped to the value of string dos. So let's see. On line 25, we have an assertion that 2 things are equal. Something is equal to babblefish bracket, bracket 1 bracket. All right, so this syntax here is how you look up something in the dictionary. So we want to know what the value is in the dictionary for item 1. All right, so for key 1, we're looking up a dictionary's key by its name. In this case, it's the string 1 because our first key for the first item in the dictionary is the string 1. So what is the value? If we looked up in the dictionary, what is the value of 1 in the dictionary? That is the string uno. All right, and the value of 2, looked up the same way, is dos. All right, run it. And that was correct. All right, test changing dictionaries. Okay, so babblefish, line 29, we've got a dictionary, or a variable, set to a dictionary with 2 items inside, 2 key value pairs. Then we access the key 1 inside that dictionary by using this bracket syntax. And we set it to string 1. So I believe what's happening here is that we are accessing our dictionary and we are switching or changing, setting the value of key 1 something new. And in this case, it's going to be 1. So we're like, hey, get me this key 1. That's what's happening here. And set that value to this other thing I'm giving you, which in the case of line 30 is the string 1. All right, so that's done. Expected equals, okay, so what is expected? What is expected? So expected equals dos, 2 dos, 1, I'm going to assume 1, although I don't know why they're not in order. That's kind of odd to me, but maybe there's no order in Python dictionaries. Are there orders in, actually there probably aren't orders in Ruby dictionaries either. So they, as long as, well, let's see, we'll find out. So assert dict equal expected, which is this one here on line 32, and Babelfish. All right, so we're going to claim that those are equal. Let's confirm, which they are. So that's a key finding in this video, that a Python dictionary is equal to another Python dictionary as long as the keys and values are the same. They can be out of order and they're still equivalent. That's important, it sounds like. All right, so Babelfish and Expected are assert, dict, equal, that there are two equal dictionaries. That's what that just showed us. Test dictionary is unordered. Okay, we just kind of did that, I thought, but let's do that again. Dict1 equals dictionary with two items, 1 and 2. Okay. Dict2 is the same thing but reversed. Assert equal, dict1 equals with a double equals dict2. Whenever we see this double equals sign, it's going to return true or false. So we need these two sides of this equation to both be the same or equal in the end. So if dict1 equals dict2 is true, this side's going to be true. So that's why I put true on this side, because that's what will be equal when the result of this little equation happens. Let's confirm that. All right, I think that was correct. Keys and values, yes, that was correct. So as we said in the prior example, two dictionaries can have the same keys and the same values for those keys in any order, and they're still equivalent in Python. Test dictionary keys and values. Okay, so we've got on line 43 here a variable called Babelfish with set to a dictionary with two items, 1 and 2. We're going to say, okay, assert equal the length of babelfish.keys. All right, so let me just use this as an opportunity to go over to our REPL and just mess with this a little bit. So Babelfish equals, and actually we'll change it up. Showtopfish. All right, so showtopfish.keys, what is that? Built-in method, keys of dictionary object. Okay. Babelfish.keys. Oh, I see. Maybe I have to give it, I see. So, and then let's do values. All right, so what was happening here? I can't do that. Okay, so what was happening here when I said showtopfish.keys, I think this is like a class attribute that gives you some information about the thing that it's called on. Built-in method keys of dictionary object. All right, so this tells me some information. And the reason it does that and it doesn't behave or do something to perhaps manipulate or really doesn't do like an action is because I didn't give it these parentheses. So it's an interesting nuance to keep in mind. The only thing I changed in both of those method calls was the fact that I gave parentheses to this one and it returned something different. All right, so what does it return? So the keys for showtopfish, which is defined here as this dictionary, is a list of two values, the string 1, the string 2. So these two guys. And the values method returns the values. So if you want to get all the values in a dictionary, you can do that. If you want to get just all the keys in the dictionary, you can do that. So knowing that, we believe what? That the length of the Babelfish keys is going to be 2, because there are 2 keys in that dictionary. Its values are going to be 2, because there's 2 values. Assert equal. Something needs to equal 1 in Babelfish.keys. All right, so I think this is a question, and it's saying, is the string 1 in the list that is returned when you call babelfish.keys? Well, what is the list that's returned when we call babelfish.keys? That's the 2 keys in a list, 1 and 2. So if the string 1 is in the list that's returned, return true. And so therefore, if we want these 2 items in the method as passed as arguments to the method assert equal, if we want them to be equal, they both need to result in the same final thing. And in the case of this line here, 1 in babelfish.keys, I believe the final result of that little equation is going to be the Boolean true. Let's confirm. All right, so where did we get to? Line 47. Okay, so that was correct. All right, so self, assert equal, something, and then 2 in babelfish.values. So is 2, the string 2, one of the values? No, I think this is going to return false for that reason. Line 48. Assert equal uno in babelfish.keys. So is uno a key? No, I'm going to say that's false. Flas. And then is dos in the list of values? Yes, I'm going to say that's true. Excuse me. All right. All right, let's see. Last one. Yes. Test making a dictionary from a sequence of keys. All right, so what do we got here? We've got, on line 52, a variable called cards. And it's set to a dictionary. It's set to, I should say, the result of whatever this does. So we kind of do like an order of operations. It's almost like in multiplication or just in, those math problems where there are multiple operations happening, addition, subtraction, multiplication, division, where you kind of have to do things in an order. That's basically what happens with these. So we need to know what cards gets set to. We need to determine what the result of this code is going to be, what this order of operations is. We need to work it out, the equation. So let's do that real quick. All right, so we can start on the inside, and we see that we are passing to a method called fromKeys. Okay, we're passing to a fromKeys method 2 items. The first is a list of strings. Red warrior, green elf, blue Valkyrie, yellow dwarf, confused looking zebra. And the second item that we are passing to the fromKeys method is the integer 42. Okay, I still have no idea what that means. All right, and then we're going to call that method on our dictionary. And so what that method is going to do, let's read this thing. Test making a dictionary from a sequence of keys. So create a dictionary and maybe make it so that this first set is all keys in the dictionary. And maybe this second set, or this second item that we pass to that method is the value to each of them, or maybe like the length. No, that doesn't seem right. The value to each of them. So I think what we will potentially end up with is something that looks like this, where we're going to have a key and a value of 42. And then comma, comma, comma. All right. And I think if we want to make that syntax a little bit better, no, that's not what I wanted. All right, so I think this is the result. Now to comment, you can comment in Python and other programming languages using this hash symbol. And that means it's like a note to yourself. It won't get run as code, but you can put actual notes in English in there, or you can do stuff like this, or really anything you want. This code does not get run when you add a comment. I'm curious now, if I was correct, what this generates. So we need to go to Python 3, press up arrow a few times, there it is. Drop this code in, and I want to see what cards it looks like. And I was correct. So it created a new dictionary, or it basically added to the dictionary that this from keys was called on several keys defined by the list passed in as the first argument, and set them to values defined by the value passed in as the second argument to the method from keys. All right, so knowing that, this is the data structure that we're working with for these assertions. Length of cards. So I'm going to assume, well, I don't need to assume, I know. 1, 2, 3, 4, 5 items. Let's confirm. 5 key value pairs, and that's the length of the cards dictionary. Blah, blah, blah. Was that correct? 55. Yes, that was correct. All right, line 55, assert equals something cards green elf. All right, so we're accessing a value in the dictionary by its key, and the value in this dictionary associated with key green elf is 42, of course. And then the value, again, we're accessing an item in the dictionary. The value of yellow dwarf is, of course, again, 42, because all of them are set to that 42 value. Let's run it. And now we are on a new file. All right, I think that is going to be it for the night. Short and sweet, about 35 minutes. There were some important concepts in that study session that we just did. So if you have questions about anything, or if I made any mistakes, or you spot inefficiencies in how I do things, I'm definitely all ears, because this is all about learning and kind of putting into words and simple terms what is happening here, and giving people vocabulary to be able to speak about it. I felt uncomfortable for a long time because I didn't have the words to describe what I was looking at. So I'm trying to really speak through everything I see to provide that. So hope that helps. See you all later. Have a good week, and see you on the next one. Bye.